All right, vectors, geometric approach. So the top three here are all different ways to make vectors our notation. So if you see these are just vectors. This top one is just supposed to be a bold V, okay? So it's just a bold V vectors. If you have something, just a number, we call that a scalar. Sometimes we might multiply a vector by just a number, okay? And whenever you have these absolute value symbols around our dark V, that is the meaning for magnitude. One of the main things with vectors is they give us a sense of direction with where an object is possibly going. Hence the arrows around some of these notations for vectors. To find the magnitude, we have 3, 4 right here as our vector. All we need to do is change in x squared plus change in y squared and find the square root of this whole thing, and that will get us our vector. And 3 squared plus 4 squared equals our vector. Square root of all that, that's going to get square root of 25, which is 5. And there is our magnitude. So if we need to try and find the components, the x and y value of your vector, we need to think about, one, what our angle is, and we'll use theta, as that's the angle measured from the positive x-axis. And in order to find the horizontal change in your vector, it's the magnitude times cosine theta, and the y magnitude times sine theta. Let's say, for example, we have a magnitude of, I'm still in laser mode, magnitude of, let's say, 425. And we have an angle of 36 degrees and 10 minutes. What would our x and y, or our horizontal and vertical vector components be? So we use our formula, 425 cosine of 36 degrees and 10 minutes. That'll be for your x. For your horizontal, for your vertical, it's this. 6 degrees and 10 minutes. And your solution will be x component will be 343, and for your vertical it would be 251. Let's say we have a ship, and this ship, we'll say it travels 130 kilometers. And it is bearing south 42 degrees east. How far east and how far south has it traveled? So if we're going south, I'm going to dot this, and then 42 degrees east. So it's going to be actually right there, that's 42 degrees east. And it traveled 130 kilometers. I almost put degrees. Kilometers, there we go. And from here, there's a couple different ways you can kind of look at this. So if we're looking at it as from the x-axis, quote unquote, it's actually 48 degrees, right? So whenever I'm doing my magnitude is 130, that's how far we traveled here. So it's going to be 130 cosine of 48, comma, 130 sine of 48. And when you get that, you'll know that you went 97 kilometers south. That's based off the sign of 48 times 130. And then you also went east. That means left and right. So you went 87 kilometers east. Work. So the formula for work is W equals, W being work. Let's label that work. Equals force times cosine theta. Of course, that is your angle. And it's the angle between force and line of the motion of the object, and d is distance traveled. Let's say, for example, that we have a package that's pushed across the floor at a distance of 75 feet. So distance, as Larry said, the problem is 75 feet, so I'll just throw that there. By exerting a force of 41 pounds downward at an angle of 20 degrees with the horizontal, how much work is done? These word problems, they pretty much tell you everything. 20 degrees horizontal and 41 pounds downward of force. So with all that information, let's use our formula. So F is 41 cosine 20 times 75. Put that all in. What do we get for our work? We will get approximately 2,890 units. For this will be feet pounds. And then, of course, we'll be doing quite a few more of these related to work and vectors in class. So I appreciate you watching, and we'll see you later.